In order to figure out what the function is, I'm going to look at what happens to each point. So if I look at the x's, they look like they're all getting multiplied by 1/3. So that means I would have 3x, the quantity squared. And then all of the y's are getting added by 1. That's plus 1. So this would be what's actually happening to the points. Now, if I didn't know what the points were, could I say something like f of x is equal to 9x squared plus 1? Does this function have a vertical stretch of 9? Well, in one sense, yes, because if I didn't know what the points were, then I could write this. But since I'm actually caring about what happens to each of the points and what happens to each of the x values and what happens to each of the y values, I want to make sure that I'm treating it with making sure that each x and y value is cared for in a sense that I make sure that I know where it goes. And so while both of these functions simplify to the same thing, if we're caring about the actual transformation of the value, this would be the correct answer. Okay, problem 2. Notice that my quote-unquote vertex value has moved a lot. So what I'm going to do is I'm going to look at the x's first. So do I just subtract 2 everywhere? Yes, it looks like all I had to do is subtract 2 for the x's. So f of x is equal to the square root of x plus 2. So I have a left move of 2. For the y's, it looks like everything is getting subtracted by 4. So I put a minus 4. That makes sense because I'm going up 1 over 1 and up 2 over 4. So I don't really have any sort of multiplying stuff that's happening to my points. So I don't need to have a stretch value for either horizontal or vertical. Now that I get to problem 13, this is a little bit more complicated. So if I'm looking at this, let's look at the x values first. This one doesn't change. This one doesn't change. And this one doesn't change. So that's actually easy. F of x is equal to x cubed. I don't have a shift or I don't have a stretch. Now for the y values, it looks like the first thing I have to be aware of is that I have some sort of multiplying effect, because normally when I look at the y values, they are going up by 1, like -1, then 0, then 1. But here they're going up by 2's. So I have to have a 2 here. So I'm multiplying all these by 2. So this becomes a -2. This stays 0. And then this goes to 2. Now what happens after I multiply? Well, -2 becomes -3. 0 becomes -1. 2 becomes -1. All of them get subtracted by 1 then. So if I look at it in its components, that's kind of what happens. For this one, all my x values have become multiplied by 4. So f of x is going to equal the absolute value of 1/4 x because they got multiplied by 4 and there was no shifting. Now let's take a look at the y's. The y's are the y's, instead of -1, 1, now it's at -1, 3, 2, and 3. So what I have to do is I have to realize that I didn't really do anything other than add 2 to all of these. So I just put +2. I don't have any sort of multiplier going on with the y's.